Hello Roshan, what's up? How's everything there? Yeah, I'm good. How are things going? That's great. Okay. Yeah, I get it. So you want to intuitively visualize and understand how two functions will be added, right? Is that what your question is? Yeah. I will get back to you, Roshan. Give me some time. I can call you back.
What's up, senior? Suddenly falling to samadhi?
Nothing like that. Nothing.
Yeah. What are you thinking? Doing some thought experiment, or are you thinking like Oppenheimer and Albert Einstein, or are you solving the unleft problems by Albert Einstein or quantum riddles? What are you doing?
No, actually trying to solve one such problem.
Seriously?
Yes.
Quantum riddle?
It's not actually quantum riddle.
Unsolved problems from space. So that deep you're thinking. What's up? What's going on?
No, I just actually had a question from my brother. So he asked me like, how do you visualize and intuitively understand addition of two functions? For example, f of x plus g of x.
Okay. Fantastic.
So I was stuck into a maze. I couldn't find any answers.
Okay.
So
what do you want to do now?
I'm not sure. I have
You
no
keep
clue.
on thinking, or are you going to do that?
I'm not sure, lead.
Let's explore.
I wish you could explain me something.
Sure, let's explore. Let's enter into the magic of mathematics. Let's see the movement of ball which is thrown in air. So that's our origin, and when one guy has threw the ball from there, so your x-axis is horizontal distance and your y-axis is your vertical distance. Hence it is two-dimensional space. When the ball was thrown from the origin, let's take it as that the ball point as the origin, but the ball has been thrown from intercept at a certain value on y-axis. So this is our origin and this is our intercept. Now when the ball was thrown from there, now we want to model the movement of ball through air using mathematics. Is it possible? As it is possible. However, first what we need to understand is how many units the ball is moving in horizontal direction. That is your how many units is covering horizontal distance. Based on that, we have to calculate how many units is covering in vertical distance, which is height. So if you see here, let me stop the ball here. I'll stop the ball here. So I'm stopping it here. Let's pause it there. Now you see it has covered 1 unit of x. For that, it has covered how much of height? It has covered square of x units. Similarly, I'm stopping the ball at the second place. You see it has covered x unit, and how much of height it has covered? It has covered the square of x units. So if you put it into the mathematical equation, so this can be the movement of ball through air can be modeled as y is equal to ax square plus bx plus c. So here a value and b value and c values are coefficients. Now to understand the addition of two functions, let's take two events which are happening parallelly, which are happening at a time. Okay, the first event, so this guy has threw a ball into the air. Okay, that event can be modeled mathematically, and that function we can call it as f of x. And there is a flight on the runway which is going to take off. So now let's model this event, the flight taking off event, as g of x. So now you have f of x and g of x. One is the movement of ball in air, and second one is movement of flight in air. So the first event can be modeled using quadratic function, that is our f of x, and the second event can be modeled using linear function, which is obviously we are calling as a g of x. Okay, now what does addition of f of x plus g of x, what does addition of your two events? So here addition of two functions is nothing but asking the total distance those two cumulatively is going to cover for the 1 unit of horizontal distance. Okay, here in this case, let me stop the vehicle here. Let me stop the ball here. I'm stopping the ball here, and I'm stopping the flight. Okay. Now, if you see from the x-axis, the flight has covered y1 distance, y1 height, and if you take the ball has covered, let's take it as a y2 distance. Now when we say f of x plus g of x means it's the total distance they have covered at any time for a unit of x distance. And here y1 plus y2 is the total distance they have covered for the respective horizontal distance they have covered. So now this is for one instance. If you want to plot it, if you want to graph it, total distance of both events at a time, we can plot it by summing up f of x function and g of x function, and then what you get is another plot where it will give you the total distances of these two at a time for various x values, various horizontal distances. What you get at the end is total height of both at a time for various horizontal distances from origin.
So let's understand adding of two functions. So when we add two functions together, f of t and g of t, right? So it's like we are adding the distance, two distances or the positions of, let's take an example of a ball and a flight. So we are adding the position of the ball and the flight at that particular time. So the result of addition gives us the combined or the total position of both of the ball and the flight. So in simple terms, adding two functions together means we are combining the positions or the locations represented by the functions to get a new position that represents their combination effect or result. So it's like adding up the distances or the position of the ball and the flight taking up to find the total position or the location of both of them at a specific time.
Exactly, that's it, senior. Do you know that this world is a manifestation of mathematics? The magics around you, the mathematical magics around you is everywhere. These are all around you. Noticing or unnoticing is only dependent on the mathematical consciousness that you have. So with that, we will be getting into the applications of addition of functions. So let's begin with the probability and statistics, because that's what is the bread and butter for a data scientist. So addition of probability density functions or probability mass functions is employed to compute the overall probability in certain scenarios. For instance, when calculating the probability of mutually exclusive events, adding their individual probabilities gives us the total probability of any one of the events occurring. The most important one, signal processing. Addition of functions is essential in signal processing for tasks like noise reduction and signal combination. In audio processing, adding background music or sound effects to a recorded audio track involves combining multiple signals. Similarly, very important aspect in image processing, adding images with different properties or attributes can create composite images. So these are related to the data scientist. Let's have a sneak peek on engineering and physics. In electrical engineering, the addition of functions is used to combine signals or waveforms. For example, in audio engineering, adding multiple sound signals together can create a blended or mixed audio output. In physics, adding forces acting on an object helps determine the overall force and resulting motion. So, as I have told you, some applications that I got into my mind. So now, do you have something to say?
That was a very good summarization, Lee. So I do have some points to add on top of you. Addition of colors. So color mixing is one of the important application. So addition of color functions or color channels is widely used in color theory and digital imaging. So in RGB color space, adding the red, green and blue color channels together in different properties generates a wide range of colors. This additive color mixing is employed in displays, lightings and visual media. Finance and economics, addition of functions is used in financial modeling and economic analysis. For example, in portfolio management, adding the returns or performance of different assets provided provides the overall portfolio return. So, in economics, adding individual demand or supply helps determine the aggregate demand or supply in a market. In sound waves, addition of sound. Addition of sound waves is crucial for understanding the behavior of complex sound systems. When sound waves from multiple sources combine, their amplitude add together. So this phenomenon is observed in musical instruments, sound reinforcement systems and sound propagation.